All right. I'm sure a lot of you have heard of Git. So why use a software version control system and why is Git so popular? First, we need a safe place for a team to work on their product, right? Where are we going to store our files, our code? How do we modify and organize those in a way that we can group them by releases, make changes to those releases based on patch requirements or bug fixes, make major version changes, and be able to pull and merge code from different branches or pull in different fixes from different branches well. And obviously in a larger team, you need some sort of hierarchical control where you're maybe letting new developers work on their own discrete branches, and then they may have a more experienced developer or manager who's confirming their changes before letting them get merged into a major release branch. Also, part of the purpose of a software version management tool is the ability to diff and merge, make that process easy. What have you changed? Help me move those changes from one code set to another code set. And of course, merging is the key, because that's not easy, right? Especially when you maybe have a couple people working on the same large file. So a good merge tool will let you smartly combine separate efforts of different developers into a file. Of course, anytime you can avoid merging, that'll save you some time. And we'll talk more about what that really means here. So merging code. The first step is diffing. And if you think about it, you can only merge code that you can view the differences between. So we're talking about text-based files here. In other words, JavaScript, TypeScript, Markdown, HTML, C++, Java, C#. It's not going to work with binary files like the actual Word, docx file, or the PowerPoint PPTX file, Excel XLS files, JPEGs, executables. Those aren't going to work. However, merging can be automatic or manual. So obviously, if you've got two sets of files and between those sets of, Alice changed her file first and no one changed it since then. So when you're merging the code bases, you'd say, well, there's no real conflict there. I can take Alice's file and just take it into my group. But if both Alice and Bob worked on the same file and made changes in the same area or, whatever, that could be harder to merge. In those cases, that you're going to need some sort of manual procedure, and hopefully with a little bit of automated help to help you figure out, how to bring changes from both Alice and Bob that were both working on that same one file together. And then the merging step, after you've figured out what the differences are and you think you're ready for a merge, you will do the merge, and it'll be this mix of the automatic, i.e. the easy low-hanging fruit file changes to bring over, and then any of the conflicts that you have to merge through a tool will also be captured. And then when you're all set, you'll say, I've successfully brought all the changes over from this other branch into my branch of code. And you're telling the software control system or software version control system that the understanding is that the branch you are now in is caught up to the other branch you just merged in from, and all your changes that you're saving are now changes that would be considered ahead of whatever branch you merged from. That become a little bit more obvious when we start playing with this code, why that semantic difference is important. The other thing to understand with Git is because it's so popular, and because it's basically, it's a command line tool, there's a huge ecosystem of GUI tooling that can sit on top of it, and that can make diffing and merging easier. However, how you use the tools, and more importantly, your team's understanding of how these things work and how best to do the process of working with Git can make it easy or hard. And so we're going to finish the end of this lesson talking about those best practices. Now, of course, one of the things that can be really hard is learning Git from the perspective of already knowing other software version control systems well. It uses some overlapping lingo, which means different things. And it's different from other source control systems, maybe similar to Subversion, but it's very different than things like source gear and source safe and clear case and some of those. Most importantly, it will kind of look at some of these what I'll call traditional approaches, which follow more of an exclusive checkout approach. So in those, they have this notion of a server that's like the single authoritative repository, of all versions and all files, and they typically still follow the same general notion of having, version branches and patch branches and bug branches. However, when you want to work on a file, you typically decide which physical file you want to work on from a particular branch, and you check it out. You basically tell the repository, hey, anyone who wants to work on this file, you can't. I've got it. I've checked it out like a library book. And then I can work safely and easily on my system, make all my changes, and when I commit it back to the repository, I don't have to worry about merging because I was the one who had it checked out. So I make my changes and I check it in, and there's no need to merge in that sort of an operation. Now, of course, the disadvantage of that is it means while you're working on that file, no one else can. Or if they choose to work on that file, they have to work in a disconnected mode, in which case they know their changes. They'll have to go through the effort of merging their changes back in on top of whoever ends up checking that file back in. So some of that lingo, especially the words checkout and check-in, don't apply in Git, and we'll talk about that some more. One of the things that Git does is it realizes that, it was written by, Linus Torvalds, and I believe he wrote it for doing a lot of the Linux work. And in that scenario, you have thousands, tens of thousands of people interested in working on the code base. So this notion of having any one person, locking a file out or holding onto a file for any period of time doesn't work. So this pattern is designed more for open source or large projects where you could never even consider using a exclusive checkout type policy. So we mentioned, obviously some of the problems with single authoritative repositories and many developers. One of the things that the non-exclusive checkouts, so these what we call distributed software version control systems use, is they often will have lots of branches. And what the key development piece is this notion of actually making a clone of a central repository and putting it on your development system. And so what that means is you're free to work on your cloned copy, and then you have to pick appropriate times to sync up your clone with the main repository. And there will be things that you may not be able to sync up without requesting sync permissions, depending on how they've coordinated the repository control. And before we go on, I want to mention one thing. One of the advantages of an exclusive checkout is for systems where you don't have diffable files. So remember, this whole Git repository notion is not that you can't store binary files in it. It's just that you can't diff those. And since Git is all based on diffing engine and noticing what changes are made and being able to merge those changes in easily, you can't do that with binary files. So if you're working with binary assets, particularly images, that sort of thing, other compiled code, an exclusive checkout system works because you can check out that file, update it, check it in, and you'll know exclusively what that version is. You don't have to worry about the inability to merge. So I mentioned earlier that some of the language can be confusing between what I'll call traditional version control systems and and Git. So I'm just going to go over those. For those who've only worked in Git, these probably just seem pretty intuitive. First, when you need to create your repository, you do so through init, and that will create the file structure. And I should probably mention that when you're creating a Git repository, you're basically creating a hidden folder with a bunch of file-based database in it and configuration files, and we'll take a look at those in a bit. But all you're really doing is creating a bunch of files that'll be hidden in the repository, and your Git command lines work off of your working folder and what it finds in your local repository. And then in your local repository, because it links to the remote, it can then look at those file system data based on the remote repository as well. So you would create a repo using the init command, and then you would get a local copy of that using a clone command. Once you've got the local repository in place, you need a place to work. So if you basically would start off of some branch close to what you're working on. So let's say there's a version 10 branch and you want to help on the next version of 10 release. So you might branch off the head of 10, or maybe a particular tagged point on version 10. You create your branch off that. And once you've created that branch, you're not working on it yet. You've created that branch. So now you need to tell Git that your local working folder will be based off of the current state of that branch. So you'll then issue a checkout on that branch, and that will then copy all the files from that branch that's in your repo to your local working folder. And then what will happen from then on is Git will watch that folder. It'll look to see if any changes have been made to any of the files. It'll let you know, and that will affect its state machine engine for how it's evaluating what you're doing relative to your local repository. So let's say you've made some changes, and I'll mention this earlier. The stash concept can confuse some folks. One of the big things you want to do is before doing any major changes to your local folder, like switching branches or merging or anything like that, you want to make sure that you don't have any changes in that local working folder that differ from what's already in your committed database. If it is, that leaves your local working folder in a state of uncommitted changes, and that will block a lot of operations, or it could mess up a lot of operations. So to get you out of that state when you really need to move, maybe switch to a branch quickly, and you don't have the desire to necessarily commit your current changes to the repository, you can stash them. And basically all it does is you give a name for your stashed files. It looks at all the things that have changed and just throws them in this collection for your stash. And you can either leave your files there, or it'll end up removing the changes and getting you back to a clean state in your local working folder, which means that there are still files in your local working folder. They just match the last commit in your local repository. Stash, like we said, that'll help clean out any of your changes to permit you to do other major operations. But if you're doing your normal development and you've made some changes and you've reached a certain point that you want to commit those to your local database, use the add command. And what that does is you use that on all your files if you want, or you can use it on a per file basis or per file extension. And it's your way of saying that these files that are different, I'm saying those are ones that I'm getting ready to commit. I'm putting them in the staging area so I can commit them soon. You could imagine that helps a lot if you have tons of files that have changed and you're looking through them trying to figure out, are there any here that I don't really want to commit yet? Once you've put them in the staging area and you're ready to commit everything in your staging area, you then use the command commit, and those will move the files from the staging area into your local repository. Most of the time you'll be required to do a comment. So there's a command that you can submit along with your commit that will apply a comment to your commit. I'm going to not do a pretty common practice, which is you can do both the add and the commit together with some command operation tags on commit. So you don't have to necessarily stage your files before committing them. But I will be doing that just to point out that they're two stages of the same operation. So now that you've committed your files to your local repository, you've made your changes. They're sitting in your branch that you've created. How do you share those changes with others? Well, there are a couple different things you would do. If you want to understand what changes people have made to their development branches while you've been working on yours, you can do the fetch command. And that will bring changes in the remote branches down to your local repository. And it's important to realize that it does not modify your working folder files. So all fetch does is it says, read the database on the remote repository, and you can selectively, fetch different things. But if you were to fetch all branches and all tags, that fetch operation would look at the difference between the local repository and the remote repository, and would bring all the changes from the remote down to your local. So you can use that, obviously, if all you're trying to do is compare your changes to maybe the latest and greatest on a release branch or a development branch, or look at other people's work. Once you're confident that your changes are ready to be shared, you're going to push those changes to the remote branch. There's a pull command, which it's symmetric to the push. Pull pushes your files up to the remote. Pull brings them down, but pull is really just a combination of a fetch and a merge. So pull says before I don't directly pull the files from the remote to my local machine. I say let me sync that branch on the remote to my local via fetch, and then I will pull them out of that local repository and put them in my local working folder using a merge operation. So obviously, again, if you do a pull or a merge while you have some uncommitted changes in your folder, it's going to, use some automated merge logic to replace some files that it thinks it can safely replace. And then if there's any with a merge conflict where they're trying to change files that you have also changed, it will annotate that as a merge conflict. And we'll show how that looks. Basically, they modify the file with some tags inside the text file that lets you know what parts of the text differ. And it's important to resolve that conflict before saving that file, because the file is mangled in such a way that it will break if it's compilable code like C++ or C#. If you just save that file without resolving the merge, it will no longer compile. Now, sometimes, even though you may have forgotten a diff or a merge conflict is reported, and you realize that it's a real big mess. A lot of files are showing as merge conflict, and you realize maybe you didn't pull from the right branch or something like that. You just need to back out of it. You can get out of it with a merge abort command. So we'll show those in a bit as well. Again, that only works if you initialized your merge with no changes in your folder. So again, this points to the importance of keeping your folder clean, i.e. Committed to your local repository before doing any operations like pull or merge. Some other Git commands here that are pretty useful. Blame sounds bad. It's not a verb, so you're not blaming people for code changes. It's just a way of displaying a file that can show where it thinks the lines came from, like which commit. So if it's looking at a certain section of code, it can say, well, that section of code came from Bob's changes 2 weeks ago, and here's why he did those changes. So it's really a nice way, especially if the comments have been entered well. You can easily look through a file that you're inspecting and realize, I didn't work on this file. This person worked on this change here, and that might explain exactly why they did that. So it can be very helpful. The last command I was just going to go over was the diff command, and that can be used to diff virtually anything. And again, you're typically diffing off your local repositories, so you want to make sure you've fetched everything from the remote, and the diff command will work off that to compare files in your working folder to anything, or you can diff branch to branch, or tags within a branch to other tags within a branch, or specific commits. It's very capable, and again, that's really what the whole Git engine is. The Git engine is really all about detecting differences between files, and when it stores them as differences. You're not actually storing full copies of every file. It's just keeping a change log of the discrete differences within each file. So that said, and we are going to do a hands-on sandbox thing here in a bit, I just wanted to review some recommended practices for keeping Git easy. As we mentioned, start your own branch from the branch being developed, or close to whatever you're working on, and commit and push your changes to your branch often. So your branch is kind of like if you're the only one working on it. So you might label the branch after your name, or your name in a particular feature or bug you're working on. Since you're probably the only one working on that one, you can freely commit changes every time you've done some, quantum of change to your code that could be easily described through a comment. And that's where it helps a lot too, as you've done your changes, as long as your changes are changes around a discrete concept that you can mention in the comment, then that means when you're using blame, you'll understand more clearly what each change is about. If you have a change that covers 50 files and thousands of lines, and you commit it with in one operation with one comment, whenever you look through those files with the blame command, you only get that one comment trying to explain what's going on in that particular portion of the code you're looking at. So commit often and push those changes to your branch often. Keeping up with changes. So as you can imagine, when you're working with a lot of other developers, they're going to want to see what you're working on. They're going to capture your changes. They're going to try to make it easy for them to do their merging. And so the way to do that is to keep up with other developers or with changes to the version branch that you're branched off of. And the way you would do that is you can run a diff command to see what's different, see if you're getting further away than you need to. You can also see if anyone's working on the same file you're working on, which would result in a merge conflict. And maybe you want to talk to them first, see if you're both heading in the same direction. And then the operation you would do is you just do a merge, which, if you're working off the main branch and you're working on a specific feature on a particular web page or a particular piece of C# code that no one else is working on, you can just keep running merge from the main branch, and it'll start picking up all the other changes from other developers. And that's really helpful in a large compiled project, because it'll let you know if someone's changed an underlying library or interface or assumption that might break your code. So it's good to keep that up. So you'll just keep merging that code in. And all that really does is it keeps you synced up to that branch, and it keeps telling the Git system that the changes in your local working folder are now ahead of wherever you just did the merge. So if you're constantly merging off of the main head, off the main version, Git will assume that your changes that you've accepted are that main version's head plus your changes, and that you are ahead of that main branch. And we'll see why that's important in a bit. All right. I should mention too, merging into a main release branch is often controlled. So if you're in a small team, anyone might have the ability to merge into a release branch, but that may not be a good practice. If you're working, for a few months on a main release branch, you may decide that some team leads will be the only ones that can effectively do that merge of your code into their main branch. This is typically formalized in a notion called a pull request. And what that basically means is if we go back to our earlier recommendation, which is you're constantly pulling from a release, you're constantly merging from the release branch into your development branch. such that you're consider your changes ahead of the current development branch, you can request a workflow from the team or the manager of the repository by doing a pull request. And you say, hey, please pull my changes from my branch into the the version branch. And pull makes sense because you're basically saying, I'm already merged, I'm already ahead, so you're going to pull the main repository either up to my version or pull my changes down to the repository, main repository version, however you want to think of it. But that workflow has a few steps in it, and usually this requires a GUI, a web-based front end or workflow management tool that's aware of the central repository. And so when people, or the remote repository, when people do a pull request, they'll often say, here are my changes. Here's all a roll-up of all the comments for all my changes since the last time I've been synced up to the database. I may specify some people that I want to do the pull request, some reviewers, but ultimately I may not have the option of actually doing the merge. So what will happen is a workflow gets started. Different people will look at the changes, they may comment on it, and they'll typically accept or deny / reject the merge. And obviously if they've denied it, you may have to make your changes and then resubmit. And if they accept it, then they can press the button and the merge will automatically occur into the release branch. And I should mention, the reason it automatically occurs is typically you don't do a pull request whenever there are merge conflicts. So you're constantly, if your pull request is taking a while to get approved and that main branch is changing, you may find that main branch starts changing in files that you are requesting to merge. So all of a sudden your pull request will not be enabled anymore because you have a merge conflict. So that requires you to do what you were doing before, which is you look at the main branch, you merge any of the changes from the main branch into your branch, and then once you resolve those, the status of your pull request will be merge allowed because there's no conflicts, and then you can keep requesting the pull request. One thing that people should remember too is that when you merge, you're not saying that when I'm taking the files from the main branch and I'm merging them into mine, it does not mean you're replacing them. You're telling the system that you want to do the merge. Your intent is to take the latest from the current release branch and use it as the base for your branch. But if there's some files that are coming in that you don't want to accept, or you'll end up overwriting them with your desired changes, and that will show up in the pull request. So I just want to make that point on the merging. All right, so I think after we've gone over these concepts, probably the best way to get a feel for all this is actually kick the tires on our own sandbox. So I'm going to describe this briefly, and then we're going to switch over to a command line and play around with this. So if you want to do your own Git sandbox, we can do this completely on a file system basis. So in other words, we can create a folder that will represent our remote, and then we'll have another folder on our computer that represents our local. We can create a Git repository, we can clone it, and we can play with all the Git commands and use some of these diffing tools and get a good sense for how this all works. The only thing we really can't do easily, and if someone has a way of doing this, let me know, is pull requests are kind of hard to do with this sort of a sandbox, just because we don't have a web server running that can do a lot of workflow operations for us. All right. So there's a Git command line. So if you've installed Git for Windows, for example, from the file manager, you can right click and you can do Git bash from here, and we'll show Git GUI a little later. But if you run Git bash from here, it'll bring up this window, and it's minimal. This MingW64. It's minimalist GNU Windows 64 So it's kind of an interop capable bash shell. And we're going to do everything from this window. There's a couple of commands you can do. Clear, which will clear the screen. You can list files in a folder. All the general operations. And of course, the first thing we want to do is just make sure we have Git installed. So there's the Git -- version, and it shows that we're running 2.25. We can clear the screen. And one of the first things we'll do is we're going to go ahead and set up our sandbox. So let's start by creating a subfolder under here. So let's make a directory. We'll call it remote. And we'll make a directory called local. And then we'll change to our remote. Oh, and I should probably mention that in case you weren't familiar, almost everything in the shell, if you start typing and it's pretty obvious what the rest of the text should be, hitting tab should complete the line for you. And that'll work for both our shell commands as well as most of the Git commands. So we're going to cd to the remote. We're in the remote folder, and we're going to create our first repo here. And remember, that's the git init. And I should probably mention too, when you've installed Git for Windows, you have access to Git help. And so if you type git help, it gives you a bunch of these commands, and you'll recognize some of these commands that we've already discussed. If you want to see the specific help on them, you could type, for example, if it's git help init, you'll see that the command line moves and you don't really see anything. You may be wondering what's going on. Well, what's going on is you just launched a browser window. And so this is the window that comes up, and you can see here's the manual page on git init. Now, the only downside with the Git documentation is it's pretty dry. It's obviously comprehensive. It covers everything, but can be a little hard to see what's the more common routine from the less common routine. For this purpose, you may find it's easier to search online for Git cheat sheets or helpful pages. But I just want to let you know that this all has integrated help, and if you need to know any specific details, we're all here. We're going to be using the git init bear. So this creates a bear repository. And so I'm going to go ahead and minimize this. And we're going to go ahead and clear our screen out. And we'll just say git init bear, and then the name of a repository .git. So in this case will be sandbox.git. So it just did it. That was fast. What did it do? You'll see when we do a list, it mentions this hidden file, the sandbox or hidden folder, sandbox.git. And we could take a look at that. And you see here we've got some small files: config, description, head, reference, objects, hooks, info. We will find these starting to if we were taking a look in them, we would start finding them building with various files that it uses as part of its database. For at this point, though, don't need to worry about it. Just know that it's all file-based database management. And at this point, all we really need to do is go back to our command line and clone this to our remote. So, and I should point out here too, because we're in this bash shell script, paths will be annotated this way. So whack the drive letter, whack the folder names, forward whack, right? So let's move ourselves up to the local folder, which is where we're going to put our local repository. And you obviously don't have to use these names. I just chose them for clarity in this case. So we'll go up, and then we'll change to local. And you can see we've got nothing in that file right now, or in that folder right now. And we're going to do a clone. So we're going to say git clone whack d whack git whack remote, and then the name of our Git repo. So that was sandbox.git. And it gives us this warning that we've cloned an empty repository. That's fine. And we're done. And if we did an ls here, you'd see we have this sandbox folder. Now, that's the folder we're going to need to change to, right? So we are not yet in our repo folder. So let's cd to sandbox, list there. And you see we're not showing anything, but there is something there. So let's go take a quick look again with our File Explorer. Here we see a hidden Git folder, and it'll look familiar, right? So it's all the same stuff that was in our remote. But again, we're not going to worry about that. Just wanted to let you know it's there. And that's how any tool knows that the repository you have is a Git repository, is because that the folder is there. Okay, so we've cleared our screen, and oh, I should mention you can, from the bash script, see if your files are there. So that's just ls-all. And you can see there we've got the .git hidden repository. All right. So we've got, we're in our local sandbox. This blue parenthetical text master is telling us that we're on the master branch. So one of the things we probably want to do first is set up a development branch. But perhaps to make a point a little clearer, we're going to start off by putting one file in our master branch and committing that. So let's go ahead and first check our status. So a command that you're going to use a lot is git status. So we're on branch master and no commits yet. Now, one of the things I wanted to do is I already have a very simple file, just a simple HTML file. I'm going to copy that and I'm going to put it into our local sandbox working folder. So I'm just place that there. So what happened when I did that? If I now just go git status, it says we have an untracked file. Nothing added to commit, but untracked files present. And it'll tell you, that's a nice part of the command line. It's usually telling you the most likely thing that you need to do at some point. So we are going to go ahead and add this to our staging area. So again, that would be git add. Now I could type out basic HTML and just do that specific file, or I can use the dot command, which means anything that's new. Okay, and so now I can do a git status. It says no commits yet. It says that to be committed, I can either remove the file or I can commit it. So we're going to go ahead and commit that from the staged area. And the most common way to do that is to combine the git commit with your comment. So we'll say git commit, and we'll put a -m for message, and then we'll put a quoted text. And this can be multi-line if you want, but this will just say, you know, initial with basic.html. Not very helpful, but you get the point. So now we can see we've committed that to our local repository. We've got the one change. If we do a git status, it'll say, hey, your branch is based on origin master. Oh, but we don't have an upstream master. So what we need to do now, and this is one of the more tricky, well, relatively tricky things with Git, is that if you create a branch on your local, do you have a branch on the remote? No. You may have to tell Git that you want it to take your branch and create it on the local and associate, or on the remote, and associate that branch that you're pushing up to the remote, pushing up to the remote with your local branch. And there's a relatively new command added to Git, which is, it's -u, which means, use the upstream source. So the way we would push this up to the master is we would, in a tracking, we would say, hey, we need to push that. So git push. and we need to tell it to sync with the upstream source -u, and the upstream source is origin, and that's the remote, and then the name of the branch, which is the one we're on, master. And so that pushed that up to the remote. So now we've committed that file to our local master branch, and then we push that master branch up to our empty. Remember, we created an empty repository. Well, that now has our master branch in it. So we should be completely synced up. Now, what I thought would be a good way of going over this is to go back and forth between GUI tools and the command line. We'll be doing all the changes of our command line, but we'll be looking at how they look from different command line tools. So the one that is the poor man's one that you get for free. Remember, we talked about when we're on file editor, and here we are in our local tool, our local Git folder, working folder, and there's our hidden folder, which is our Git repo. If you right click in here, remember we had that Git bash, which is a command line. We now have the Git GUI. So if I hit Git GUI, you'll see the user interface that you get. And unstaged changes, stage changes, you'll see that there's a lot of commands here with respect to branching, committing, and merging, fetching from remote. There's a lot of options here. This is not my go-to GUI. We'll show you some others because there's plenty of free ones out there. One of the more popular ones that's free, or I shouldn't say free, there's a free version of it, is Sublime. This is actually a merge that's in process. So I'm just going to go ahead and cancel that merge. And I'm looking at a different repository here, but you see they're showing, colorful breakup of the different branches. You're seeing differences being recorded. This is the Sublime merged. I'm unregistered. I'm using the free version. It's doesn't have all the features, but it's got a pretty good set of features in the free version. If you're in a development team using the Atlassian stack, which is probably one of the more popular, if not the most popular, paid commercial package, they have a pretty nice tool, Source Tree. And the Source Tree, again, has this whole notion of being able to see these, the remote branches and the local branches, and being able to do your diff, etc. What I'm going to do here is I'm actually going to open our Sandbox one. So I click on the tab, and then I add a local one. And we're going to browse that same location. So we're going to go to Git local Sandbox. And because I can see that hidden Git folder, I know this is a valid repository. So click OK, add that. And then now we can see that I have a local branch. And then on the remote origin master, we have the same file. And I can take a look and see what that file looks like. And we can see that that was all pluses means that file was all added. All right. So we'll come back to this, and we'll be using this as one of our primary viewers. I tend to use Source Tree just because our team uses the Atlassian tool stack. But I will say that for merging, I really like the Sublime merge. But there's others. I'll show you some other ones out there for doing merge as well. Okay. One of the things I did forget to mention is that most of these things are all accessible from your bash shell. So the Git GUI is simply Git GUI, right? And that'll run your user interface tool. The other thing I want to mention is that if we run, again, git status, that's kind of our go-to, git status, it's telling us we're up to date. If we were behind, do you remember what the command is that we would need? What do we do if the master is ahead of our current master branch? We would do a git fetch. And again, that doesn't change the working folder. All it does is say, there's information in the remote repository that's newer than my clone. So please go fetch it and update my local. Because these can be big and the operations could, in theory, take a lot of time, you can be selective about your fetch. You may only care about a particular branch. If you don't, you can just do git fetch, and then it's all. And obviously, if there's nothing to do, there's no issues. And again, if you wanted to look at the help, git help fetch. And again, we just remind ourselves that it's going to pop open a window, and here's the man page for git fetch. And you can see it'll give you all the different things you can do here as far as fetching from the remote. All right, so I think now it's time to create a working branch, and I'm going to simulate being different people at different times. So the first thing I want to do is let's just see what branches are out there and which ones are available so I don't collide. I don't want to create a branch that already exists or try to. So it tells me all we've got on the remote we have a master, and locally we have a master. So we can create our branch, and we're going to go. I'm going to keep things simple. I'm just going to name the branch after the developer. What you might do is actually after the developer and a particular issue they're working on or bug fix or whatever. But we're going to keep it simple, or we're just going to say git branch Alice. Now note my master, I'm still in the master branch. So that, again, it was just a database operation that said create a branch called Alice in my local repo. Don't do anything to my folder yet. So in order for me to switch to that, if you recall, I have to do a checkout. So I'm going to go git checkout, and I'm just going to type A and then tab, and that completes the Alice for me. And says switch to branch Alice. So now we see Alice there. Now what do you think is going to be in my folder? Because we branched off of master, I should be starting with whatever was in master. So if I list what's there, you can see I've got my basic HTML file. So now I can start changing that file. So we're going to go ahead and make some changes in there, and then we'll check it in. And then I'm going to go ahead and go back to master, branch off of Bob, and we'll do some changes there, and we'll create a conflict and a non-merge conflict. So one of the things I like to do, I've got Visual Studio Code installed, and that executable is just called code. So if I type code version, I can see that it's installed. And that means if I type code and then the name of the file, like basic HTML, again, I can just hit the tab, that'll launch my code editor for basic HTML. So here's that file. This is in, let me get rid of this file here. So here's my basic HTML file. Not a whole lot in here on purpose. At this point, I just wanted to mention most people are familiar with Visual Studio Code or VS Code. It's an awesome open source editor built on the Electron platform, which means it works on all the different operating systems. And I've installed a few extensions here. One of the extensions that is going to be useful in this discussion is GitLens. That adds some features. So out of the box, you still get pretty good Git integrations with Visual Studio Code. What GitLens does is it lets us see things like, hey, I've got 2 source control providers it was aware of. I've got this other simple one here, and you can see the 2 here means I've got some changes that need to be handled. And if I go to the sandbox we just created, you can see it's telling us we're on Alice branch, and I can hide that so it doesn't distract us. And then with our file here, we're going to go ahead and make some changes. So we're going to make, let's change this color to green. Let's put by Alice here. Comment changed by Alice. And then maybe another little change little code here. Okay, and we'll make one other minor change here. And then we're going to create a new file in this folder. So let's just do a file, new file. We're going to do a markdown file. So let's go ahead and save as. We'll call it Alice Markdown. We're just going to start off with Alice's code. Doesn't matter what I do here. I'm just trying to put a little something in here so some people can see what Markdown looks like. That's auto saved. So I've got those two files saved. Basic HTML is done, and it'll show me, you know, what changes I made. So here are the changes that we made to that file. If we go to Git, it'll show that these two files are changed, and we could go ahead and hit the plus signs here, which would stage those changes. I could discard the changes, so roll those back. And then I could, once they're staged, I would have the ability to commit. So that's what this checkbox here is. So typically in this GUI, let me slide that down a little bit better so you can see it. In this GUI, we would be able to hit the plus sign or this one plus sign here to stage all our changes. We could type in our comment and then hit the checkbox, and that would commit it to our database. And then if we hit the sync, here we could push our changes up to the repository. So again, you can do all that through a GUI here. We're going to go back to our command line, however. All right, so I've made those changes, and again, I can see the same thing with the command line here. So let me go ahead and clear screen, get some usability space here. Let's do a git status, and we can see we got the modified basic HTML and the Alice Markdown here. You could always just, cat if you want to look at them, say cat Alice, and that shows what's inside there. And we could cat basic, let's see what's in there. Let's clear the screen. So now what do I want to do? I want to stage those changes, right? So I'm going to go ahead and do the git add command. So git add, and again, I'm just going to do .everything. So this is going to put my changes in the Alice branch. Now they're staged. Now I want to commit them. So I'll do a git commit with a comment, added my readme. And fixed a bug in basic HTML. Of course, a very bad comment, but you get the idea. And I honestly don't remember if I can use single quotes or not, so I'm going to make sure I put double quotes. Okay, commit's made. We'll look at git status. So it says we're on Alice, working tree clean. So again, that's the big thing we want to keep seeing, right? We don't want to do anything major. We want to switch branches or merge unless we see that git working tree clean. All right, so we made our change in Alice, and now we want to switch back to master. So we can check out, let's start with git checkout master. Oh, gotta spell it right though. Okay. So notice here we lost our Alice Markdown, right? So that's in Alice's branch, not in ours. And we're going to create a branch off of here for Bob. So we're simulating both Bob and Alice started with the master branch, and they're going to go their own different directions. So do you remember the command for creating a branch for Bob? Well, that was pretty simple, right? It's just git branch Bob. All right. So we're going to do something similar. We're going to actually create, do the same thing we did on Alice, but a little differently. We're going to, again, launch basic with code. There's Alice's file. And we don't care about that one anymore. What did I forget to do? So I'm about to make changes in what I thought was Bob's branch, but I'm still on master. So I created Bob's branch, but I didn't switch to it. And you can see here by our master indication that we're still on master. So remember the command for switching to Bob. That was git checkout Bob. Okay, so now we're on Bob. It should still look the same, right? I'm gonna clear screen, and we're gonna go code basic HTML. So here we are. Hey, that's good. We're now on Bob. We're gonna do very similar changes. We're gonna do one other thing that's gonna be a little interesting. How do these diffing engines deal with white space changes? So one of the big issues that can cause a lot of consternation is when people make white space changes to a file. So it'll show the file is quite different, even though semantically there's no difference. So for example, I can format this document, and you can see it changed its look and feel quite a bit, although we didn't really change this file in any meaningful way. Some files, obviously, that could make a meaningful change, but with respect to HTML or our code like C# or Java or whatever, it won't make any difference. Okay, so I made that white space change. We're going to do something that we know will be a little different. Let's go ahead and make this comment here, but this time will be by Bob. We'll change a color. This time let's use the the tool. Come on. For some reason it's not coming up. Doesn't matter. Oh, there it is. Jeez. I guess I have to click over here. Let's pick that color. All right. Then we're going to go ahead and save. Turned auto save off here. So I made a change, and now you see it's showing that basic HTML is different. And we're going to make we're going to do kind of the same thing. We're going to create a new file. We'll save it as Bob Markdown, and we'll just say, hey, let's go ahead and just put one little call it a day. Hit save, and that should pop up here. It's right down there. Again, I'm not going to use the GUI yet. We're going to just do it for editing. I'm now going to go get status. We see that we have a modified HTML and a new Bob Markdown. We're going to go ahead and take a look at source tree, by the way. So source tree, you see it. I didn't do anything. It just adapted. Said, oh, we've got a master. We got Bob. We've got Alice. We can see we're starting to build up a tree. We can see that Alice is sitting there on a branch ahead of master. We see Bob right now, at least with respect to the database, it started at master, so we're still showing that Bob and master are there, but we have uncommitted changes. And then there's some iconography here which says, well, the basic HTML yellow means that was changed. So we can click on that and see what the changes were. And then the question is, hey, this is probably a new file. I'll go into this in a bit. There's this notion of ignoring files. So if you put a file in there that was pure garbage, you might want to ignore it. It's probably a good idea to go ahead and do that. now. So let's take a look. Let's go back to our command line. And let's just touch a bad file. So we'll just say, hey, touch bogus file.jpg. So that just made an empty file called JPEG, and if I do a git status, we can see that it's showing up as a new untracked file. And if I wait for this thing to sync up, it'll show that bogus file is there, and we don't want to have a binary file in our repository, so we might click on it and say ignore. I could do it same thing with the command line. I'm just going to show you how this works, because in this GUI it's going to say, hey, do you want to ignore the exact file names or anything with this extension? So we're going to say, hey, let's just ignore everything with that extension for this repository only. Hit OK, and guess what happens? We created another file. We created a git ignore file, and you can see it just has star.jpg in it. So we'll actually be committing that change to our repository in a bit, and that will that's how you manage which files. For example, let's say you're compiling your code in this tree, and it creates OBJ files or DLLs or things like that. You would fill your git ignore file with the appropriate filters, and then to be honest with you, or just to say how it's typically done, you don't typically have to modify the git ignore. Teams will have established pretty large git ignore files out there that ignore all the transient outputs from bunches of different tools. So typically all you do is use one of those canned ones for a particular type of development. Maybe it's web front-end development, maybe it's .NET development, whatever. You can find git ignores that are already pretty well populated, and then you can just adjust them as you need. But for the most part, once you've gotten going, you don't need to modify that git ignore file. All right, and if we go back to the command line, if you want to know more about that, again, it's git help ignore, and then we can go take a look at the popped up window, and it tells you all about the pattern formatting and where the file's located and that sort of thing. So, and you can use some of these samples. All right. So we've made our changes in Bob, and we want to commit them. So let's go ahead and git add. Actually, let's just take a quick look, make sure our status is looking. That looks good. We've got our git ignore, our markdown, and our basic HTML, which is modified. We're going to go ahead and git add all. We're going to git commit with comment added Bob's markdown. Okay, that's committed. Now, maybe you've all noticed that I've been committing them local, but I have not been pushing them. So if we go back to one of our GUIs, we'll notice that there's nothing here on master. There's a remote master, but there's nothing here locally. And there's the Alice and Bob are not up here, which means they haven't been pushed yet. And it's not complaining because there wasn't originally a tracking folder there. So what we're gonna have to do is create the tracking folder. So we're gonna push this folder up and let it know that we expect it to create one that's linked to this when we do it. So that requires a special command. So again, that command is going to be git push, but with the upstream command. And with that, we have to tell it the upstream, which is origin. And then we have to tell it the name of the branch, which is the same as this one. So that should push our commits to the Bob branch up to the origin and make the Bob branch on the origin. Okay, and that looks good. And you can see it tells us exactly what it did. And see, it says branch Bob set up to track remote branch Bob from origin. So that should mean that if we bring up our source tree, wait for this to refresh, there we go, there's Bob on master, right? All right. So we haven't done that in Alice yet, so we got to do that in Alice. So let's fix up Alice. So if we do git status, we see that our working tree is clean. So now we need to go up to, we need to check out Alice. Okay, so now we're on Alice. We confirm that branch. Get status. Should tell us there's no remote tracking. So let's go ahead and do the same thing. So we need to create a git push upstream tracking origin Alice. Okay, and we'll go back to source tree. And we should see Alice show up down here. So there we go. So we got Alex, Bob, master, and then we have uncommitted changes. Oh, right. So we still have the bogus file. So why do we have that? That's here because it's ignored. So it was neither removed when we switched branches nor updated. So we would have to either don't forget to delete that file or to put it in the ignore list. So I think in this case, what we're going to do is we're going to do the command line. So let's go back to command line. ls. Yeah, there's that bogus file. So can we do a git ignore bogus file JPEG? And this time I'm not going to do, let's see, we should probably keep it the same, right? So let's keep it with an asterisk. Oop. Git. That's because I have to do it through the actual file. So the git ignore command does exist on some of them, like GitHub. It makes it a little bit easier, but all we really need to do is, in this case, let's just go ahead and touch git ignore, and then we'll edit that. And we'll just do star.exe star.jpg. And there we see in the GUI it automatically hid the JPEG file for us. Go ahead and kill that. And then we'll see if we do a ls. The file's still there. It didn't show us the git ignore because we didn't do the /a for all. And there's the .git ignore. So then if I do git status, we can see we've got the git ignore there. So let's go ahead and git add, and then git commit the message updated git ignore for JPEG. All right. Okay, working tree is clean. And now we need to push. Now we are tracking. So let's go ahead and push those changes. So just git push. And it shows us that we update a remote. Okay, working folder clean. Let's go back to our source tree. We can see we got Alice, Bob, and master. We can see that those are all tracking here. That all looks good. All right. So one of the things I can show you in the GUI, and we can do the command line for this as well, is how do these files differ? So when I select these two commits, it can show that git ignore is different. We can see one of them's got the exe while they both have the JPEG. There's a bunch of different changes here in the HTML. We've got Alice in one of them. So it shows Alice is added in Alice, but removed from Bob. So that means it's only in Bob is another way of looking at it. We can go in here and we can look at file status, and we can look at all. So this can kind of show us here are all the files and what's inside them. We can again look back at history. There's lots of things you can do with a GUI like this, right? So you can right click and get all these sort of options here. Same thing with here. You can create pull requests. Of course, we don't have a GUI, so this will complain. Right? It'll say you don't have remotes configured for doing that. So I think what I want to do now is show a merge conflict. So let's look at the difference between these two, and we can see that when we click in Allison and Bob, so if Bob wanted to, if we want to merge Alice's changes into Bob, we would see that we're probably going to get a conflict between getIgnore and basic HTML. And what would probably happen is the Alice's file would come in to Bob's because it's new. It's not overlapping. So let's go to Bob's and let's merge Alice's in. So I did mention that you can use the git diff command here. Of course, the diff commands are going to get increasingly less valuable in the command line than they would in a GUI, but they are available. So we're just going to diff Alice and Bob. And again, you can see it's going to show you the difference in each file with details. Now notice you're still stuck in the command line. It's showing a colon at the bottom. You have to hit Q for quit to get out of that. Let's go ahead and clear a screen. All right, so let's go ahead and merge Bob. And let's switch to, so let's do a git checkout. Oh, before I do anything, let me make sure we're clear. So git status. Okay, working tree is clean. So let's do a git checkout Bob. Okay, so now we're on Bob. And now we're going to merge Allison to Bob. And look what we got, right? As we expected, auto merging basic.html, auto merging getIgnore. So it failed for basic HTML and it failed for getIgnore, but we don't see any other comments here, right? So that probably means if we list, we see that we brought, when we merged Alice into Bob, we picked up Alice's markdown. So no comments on Alice, that just came in automatically. So now here's where it gets interesting, right? It said that it merged, but there's a merge conflict. What does it do? How do we know there's merge conflicts there? So let's go ahead and let's look at one of them, right? So we know that there's a conflict on the getIgnore. So I have to do LSA, right? So there's a getIgnore. So let's go ahead and cat getIgnore. And notice what it did. Inside the file, there's this arrows head, these equal signs, and then arrows Alice. And so what it's telling us is, there's one thing here that's only in Alice and not in the head. And so Alice has the additional exe. So if we wanted to resolve that conflict, again, if we were to commit that file as is, it would be stuck with this file mangled with this junk in it. So what we're going to be doing is we're going to be resolving the conflict using a tool, and we're going to get it to a clean state where these markers are removed. And once those markers are removed and we say, hey, there's no conflicts anymore, we can go ahead and commit. So this is where you want to use one of the better GUI tools. And again, one of my favorite tools is Sublime. So we're going to go ahead and launch Sublime. And we're going to do let's go ahead and open a repository. So we're going to open the local sandbox. And we're going to get rid of that one. And here we can see there's the two unmerged files. It's showing that we've got a conflict. You can see this abort merge button here. It's showing me, just go ahead and collapse some of these a bit, right? So it's showing us that we have a staged file here. and that we want to try to resolve some of these files. So, and this can be a little confusing. Sometimes resolve on the resolve tool means I'm all done. Let's go ahead and accept it. On the Sublime, resolve means please run my cool tool to resolve it. So when we do it, you get this three-way merge tool, and this is becoming more and more popular in the tools. But right now, Sublime and Meld and just a few others have a capable three-way. So you can see what it does here is it says under this commit on Alice, we have exe and JPEG. Under this commit under Bob, we only have JPEG. And it's saying there's a conflict. I don't know what to do. So pretty easily, you can just say, well, I like everything that's on Alice. So you can hit this and it says use this hunk. So now Alice is coming in. And then we can say, yep, that looks good. If there's any other conflicts in here, we would look at them, but we're not. This is a small file. We'll save and stage. This basically says, I'm done with this one. Let's go ahead and stage it. Okay, so that's in our stage list. So Alice Markdown, that one came over automatically staged. We just finished resolving the gitignore, that's staged. So now we have to resolve the basic HTML one. So this one, if you recall, this was the one where we formatted the file. So it was actually Bob, because we can tell, look here, he reformatted the file. And it's quite different, even though the content's mostly the same as Alice. And you can see we have some things it really couldn't figure out. So for example, this to head, it thinks that this head is different because of the white space differences. And I'm pretty sure there's a way to tune this up to make it, in other words, we can probably set some preferences where it'll ignore the white space more. But one of the things I want to point out too is that there's, if you just want one, you can say, yeah, you take the left one or take the right one. You don't have to work your way through all of them, or you can work your way through the changes. So in this case, we saw, this one, said by Alice, and this one said by Bob, and they show as a conflict. So typically what you do is you'd pick one, and then you might come in here and just change it and say by Bob and Alice. Okay, so we'll call that one done. And then we've looked through these others and say, hey, you know what? I didn't like those formatting changes here. I wanted to not do the formatting. So we'll just go back to the way Alice had it. So that'll fix that change. But it didn't remove the one here from Bob. I thought it was going to replace it. So I am going to get rid of it manually. And then we've got some other conflicts here. And I forgot to mention, so this is where the previous and next comes in. So you can work your way through the conflicts. So it'll do the best it can automatically. So it didn't worry about this. It saw that there was a change, but it wasn't worrying about it. So really, I just have to figure out this one. So we've got color blue and color green. They clearly conflict. We can only take one. So I'm going to take that one, and I'm going to take this part of Bob's, which is a comment. All right, so it shows no more conflicts here. We've merged our stuff together. I'm going to hit save and stage. So now we're golden. Our diffs are done, and they're all staged. So I don't have to do anything. I just leave it as is. I could use the tool and actually do the commit merge with 3 files changed in this tool. I could abort the merge, which would take everything, go back to where we were. But let's just go back to the command line for now. Get status. And you can look. Changes to be committed. So these are staged. All conflicts are fixed, but you're still merging, right? So I need to use get commit to conclude the merge. So we'll do what it says. Get commit. Merge. We merged, we are in Bob, so we merged Alice into Bob. All right, now we're good to go on our local repository, but we need to tell our remote that we've got some new stuff, so we're going to go git push. Okay, and so now we'll go back to our GUI and see how that's looking. So you can see there's no more uncommitted files. Alice is now ahead of Bob, but Bob's changes I've got Alice's changes merged in, and looks like we're in pretty good shape. And you can see as we look down here, we can see the markdown and ignore files. So I think we are good. So I did want to show you what that merge looks like in some of the other tools. So this is a different merge in Visual Studio Code. And you'll notice that we don't have the 3-tier merge. You basically can accept the current change, accept incoming change, so like which one you want to do. If you accept both, or compare the changes, and if you do compare, you can do a side-by-side and you know, copy left to right, but you can't really do the 3-pane merge. So that's Visual Studio Code, and I think it's one of the, maybe by the time you see this video, this has been fixed, because I know that this is a huge request for Visual Studio Code, is to get the 3-pane diff. For the most part, we still use Sublime instead. Another option is Meld, which is just a generic open source diffing tool that is designed to work well with Git. So this probably looks familiar. Here's our 3-pane diff, and just slightly different GUI, but generally the same feature set. This one is completely open sourced and a different product base underneath it. So that's a Meld merge. And let's see, we could look at, we've already looked at Sublime. Now I wanted to show you what the GUI looks like after we've done a merge. So if you remember, we checked out Bob, and then we merged Alice into Bob. So these two branches still exist. The Alice branch still exists. The Bob branch still exists. But this is letting us know that Bob is now based on everything that was done in Bob branch plus everything that we wanted to take from Alice. So we're to switch to Alice, we can continue developing, and this would branch off and get ahead of Bob on a different branch. But I just want to let you know that that's what it'll look like when you've merged your stuff back in. So you can imagine what the visualization looks like in a production environment. You might have one of these branches here. This blue one might be, instead of master, it might be, you know, version 10.1, Service Pack 2. And you might have many different developers working on different features and bugs, and you might see them come out and do a couple of check-ins and then merge back in, signifying that they've, you know, worked on the bug, tested the bug, and then we'll check it back in. So you'll see a lot of these branches coming out and going back in, and then maybe they'll just delete the branch because there's no need to keep a bunch of noisy branches here in the origin. They may just start removing them. If they wanted to have key points to get back to, they can put a tag. So you can put a tag here, and you might say something, you know, whatever you want. This might have been Alice before refactor step 20. Oh, I'm sorry, you can't have any funky text in there. So it's just Alice, we'll just call it Alice 4.4. And so now we've put a tag in there for Alice. And I'm sorry, I tagged the wrong thing. I tagged the local Bob checkout. But once you put your tags in there, they can hang around. So as the files keep getting checked in and checked out, what will happen is that tag will stay at this commit version. It locks at that commit version. So if you wanted to create a branch on a tag, you can. So instead of creating a branch off of another branch, you can create a branch off of a tag. And typically what you might use these tags for might be a particular version number that you're releasing. Or, you know, maybe it's a tag for testers to grab stuff. So a lot of options there for tags. So hopefully that covers it. If you have any questions, please feel free to leave them in the comments below, and we can either answer them in the comments or we'll have a supplementary video or update the video. So thank you very much.